In this video, we are going to talk about electron configurations. The electrons are far more important to an atom than the protons and the neutrons are. Yes, the protons determine the atomic number of the atom and are sort of the defining characteristic, but the electrons of an atom are responsible, we will see, for the properties of the atom. They are also involved in bonding, and so overall the electrons have far more to contribute or far more importance to the atom than the protons or the neutrons do. Okay, so in this video, we are going to talk about how to write something known as an electron configuration and draw an orbital filling diagram. Okay, those two are related, and then in our next video, we'll get into how to draw the dot diagrams for the elements. So first of all, what is an electron configuration and an orbital filling diagram? Well, both of these are ways to show the distribution of the electrons in an atom. Okay, so it's a way in which we can show where the electrons, or the approximate location of the electrons in an atom, are located. Electron configurations and orbital filling diagrams are going to give energy levels, atomic orbitals, and the number of electrons in an orbital. Okay, and we'll talk more about what an energy level and atomic orbital is in a minute here. The difference between the two is that an electron configuration is going to show all of the electrons that an atom contains. So for example, carbon has 6 electrons, so an electron configuration will show the placement of all 6 of those. An orbital filling diagram is only going to represent or show what we call the valence electrons. And the valence electrons, we will see, are those electrons that are farthest from the nucleus. So an electron configuration shows all of the electrons. The orbital filling diagram is going to focus in on only those valence electrons. And again, a valence electron is the electron that is farthest away from the nucleus. So before we get into writing electron configurations, you're going to need your periodic table in order to accomplish this. And if you pull out your periodic table, you will see in the back a chart that looks like this. Okay, this right here is an energy level diagram that is going to make writing electron configurations and orbital filling diagrams extremely easy. Okay, now this chart is found on the back of your periodic table, and you will have access to it on all tests, quizzes, etc. So as long as you understand how to use this table, you should have no problem determining the electron configuration for an element. Now, when we write some electron configurations, there are some rules that we need to follow. And the rules will become easier to understand once I start showing you examples. But for now, here's what we need to know. The very first rule for writing electron configurations is that electrons are going to always enter the lowest energy level first. So if we take a look at our orbital filling diagram, you will see down here we have the first energy level. Okay, so the first energy level is located at the bottom. Okay, this is the energy level that is closest to the nucleus. And so as electrons start filling these energy levels, they're going to always start down at the bottom where the 1s is located and then make their way towards the top. Okay, each one of these bolded lines, like I said, is going to represent an energy level. So this is the first energy level, here's the second energy level, the third energy level, etc. And again, the higher the number, the farther away from the nucleus the energy level is located, and the more energy the electrons in those energy levels contain. Okay, so when we fill our orbital filling diagram here, our energy level diagram, we want to make sure that our electrons enter the lowest energy level first. So they're going to start down here at the 1s. When that's full, they'll move to the 2s, then they'll move to the 2p, then to the 3s, then over to the 3p, etc. Okay, and they cannot move up to the next energy level until all of the electrons have filled in that energy level. There are a couple of things you want to notice. Once we get to this third energy level, you'll see after that we move up to the 4s. Okay, but now after the 4s is full, we're going to jump to the 3d and then make our way back to the 4p. Okay, so that's really the only thing we have to remember here is we go from the 3p to the 4s to the 3d and then back to the 4p. Okay, and if you need to mark that on yours to remember that order, you may certainly do so. Okay, the second rule we want to remember is that each atomic orbital can contain only 2 electrons. Okay, so an orbital, when we talk about an orbital is going to be one of those circles. Okay, so this right here represents one atomic orbital. And each one of those orbitals can hold only 2 electrons. Now to show that, okay, so if this is my 1s orbital here, to show the 2 electrons, we're going to show 1 electron with a diagonal line this way and a second electron with a diagonal line this way. Okay, by making an X, then that's going to show us that that orbital is full and it's time to move up to the next energy level. Okay, so our rules for now is that we have to start at the bottom of our energy level diagram and work our way up, and each one of those circles can contain only 2 electrons. Once it's filled with 2, it's time to move on to the next one. Okay, the last rule is a little trickier, but it's this idea that when electrons occupy orbitals of equal energy. Okay, so what does that mean? That means if all of my electrons here are in the 2p, 1 electron is going to enter each orbital until all the orbitals contain 1 electron. Once each one contains 1 electron, then they're going to pair up. Okay, sometimes this is referred to as the bus rule, because if you were to get on a crowded bus with people you didn't know, your chances of sitting with someone you don't know aren't going to be as high if there's an empty seat. Okay, so if you walk onto a bus and there's an empty seat, you're going to sit in that empty seat. Typically, everyone will sit in an empty seat until all of the empty seats are full, and then people will start to pair up. Okay, so that's kind of how it works with electrons. So if I were to look at my example of carbon, okay, and we'll talk about how to do this a little more, but if I find carbon on the periodic table, carbon has 6 electrons. Okay, so I have to place 6 electrons in this diagram. When I do that, you'll see I'm going to start down here at the 1s and go 1, 2, then I'm going to make my way up to the 2s, 3, 4. Now I'm going to fill the 2p, 5, 6. Notice those electrons each fill one of those orbitals by themselves, and then if there were more, I would start doubling them up. Okay, so that's what it means by the bus rule. All right, so the best thing we can do now is start looking at examples of this. So again, you're going to want to make sure you have your periodic table out. You're going to want to make sure you have your energy level diagram as we go through all of these examples. So we're going to start with the basic one, which is the element boron. The first thing we have to do when we write an electron configuration is we have to determine the total number of electrons. Okay, so if I locate boron on the periodic table, I will see that the atomic number for boron is 5, which we know means that it has 5 protons. And because this is a neutral atom, then the atomic number is also going to tell us the number of electrons. Okay, so step number 1 is determining the number of electrons. A boron atom contains 5 electrons, which means when I go to my energy level diagram, I need to make sure that I have placed all 5 electrons. So if we think back to our rules, we're going to start down here at the 1s, and I'm going to put 1, 2 electrons in the 1s. Okay, that 1s orbital is full, so now I make my way up to the 2s. Okay, 1, 2 electrons are full. Now that the 2s is completely full, I'm going to move over to the 2p, okay, and I put 1 there. So if I count my electrons, I have 1, 2, 3, 4, 5 electrons, which is what boron has. Now we're going to use this energy level diagram to determine our electron configuration. And again, our electron configuration always starts down at the bottom. So I start by writing 1s. In the 1s orbital, I place 2 electrons, so I'm going to write it like this, 1s2. Once the 1s was full, I moved up to the 2s. Okay, and in the 2s, I put 2 electrons. And once that was full, I moved to the 2p. And in the 2p, I put 1 electron. So my electron configuration for boron is 1s2, 2s2, 2p1. Okay, it seems complicated, but each one of those numbers stands for something. Okay, so the 1, the 2, and the 2 here represent the energy level, or the distance from the nucleus the electrons are found. Okay, the S, and the P here represent the orbitals. And we're not going to get into that too much, but it has to do with the shape and the probability of where those electrons will be found. But for us, we just need to recognize that it's an orbital. And then these numbers here, 2, 2, and 1, these numbers here represent the electrons. So at the end of an electron configuration, those numbers should total your total number of electrons. And if I take 2 plus 1, it indeed equals 5. And so I know that I've placed all of those electrons. Okay, so using the energy level diagram, it's pretty easy then to determine what the electron configuration is. Now, if you recall, we said the electron configuration shows where all of the electrons in the atom are located. Okay, the orbital filling diagram is going to look at just the electrons in the highest energy level. Okay, and remember the energy levels are the whole numbers. So if I look at my orbital filling diagram, I will see that the highest energy level that the electrons in boron fill to is the second. Okay, so my orbital filling diagram is going to look like this. I'm just going to draw a circle to represent the 2s orbital, 3 circles to represent the 2p orbital, and then I'm just going to copy down what I have. In the 2s orbital, I have 2 electrons, and in the 2p orbital, I have 1. Okay, so my orbital filling diagram is only showing 3 of the 5 electrons because only 3 of the 5 electrons are found in that highest energy level. Okay, so let's take a look at another example. In our next example, we're going to take a look at sodium. Okay, and writing the electron configuration and orbital filling diagram for sodium. Again, the first thing we have to do is determine the number of electrons in sodium. So if I find sodium on the periodic table, I'll see it has an atomic number of 11, which means we have 11 electrons. Okay, once again, I'm going to start down at the 1s, and in the 1s I can place 1, 2 electrons. Then I move up to the 2s, 3, 4. Now I'm going to move over to the 2p. Watch how I fill the 2p. 5, 6, 7. Notice each one filled with 1 first, then I double up. 8, 9, 10. And now I can move 1 up more to the 3s for my 11th electron. Okay, from here, I'm going to write out the electron configuration. 1s, I had 2 electrons. In the 2s, I had 2 electrons. In the 2p, I had 6 electrons. And in the 3s, I had 1 electron. So the electron configuration for sodium is 1s2, 2s2, 2p6, 3s1. Okay, again, if I total, 2 plus 2 is 4, plus 6 is 10, plus 1 is 11. All of those total the number of electrons, which is what I want. Okay, from here, I'm going to determine my orbital filling diagram. The orbital filling diagram is the highest energy level, which I notice is the 3rd energy level. So my orbital filling diagram is going to look like this, 3s. Okay, notice there's nothing in the 3p, so I can write it and keep it blank if I want, or I can just keep it at the 3s. And in the 3s, I have 1 electron. Okay, so here is the electron configuration in the orbital filling diagram for sodium. Okay, we're going to do one more. Okay, our next example is gallium. So once again, I'm going to locate gallium on the periodic table. When I do, I see gallium contains 31 electrons. Okay, so we're using a bigger number here. I start down at the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, now that the 3p is filled up with 18, I'm going to jump up to the 4s, 19, 20. Okay, this is where it can get a little tricky. From the 4s, I have to remember to go to the 3d. So the 4s was 20, so this is 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Now that the 3d is full, I can go back to the 4p to put the 31. Okay, so remembering to go from the 4s to the 3d, then back to the 4p. Okay, for my electron configuration, it's going to be a little longer here, so I'm going to go 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Okay, notice the D, there's 5 orbitals with 2 each, so that's 10, and then I went to the 4p1. Okay, so there's my electron configuration. Now the orbital filling diagram for this one is going to be a little trickier. The highest energy level that I fill to is going to be the 4s and the 4p. Okay, yes, the 3d is in that same row, but it's not considered the 4th energy level, so I only want to use the 4s and the 4p. If I look here, I'm only using the 4s and the 4p. Okay, I'm never going to include d's in the orbital filling diagram. So here I have my 4s. I'm going to draw all 3 orbitals for the 4p. In the 4s, I have 2, and in the 4p, I have 1. So my orbital filling diagram looks like this. Okay? So that's how we go about writing electron configurations and orbital filling diagrams for elements on the periodic table.